Next up, we have Evan McGee. Evan is the CTO at SignalWire. They are a 256-bit sponsor, of course. Prior to being at SignalWire, he grew Ring Plus to be a nationwide wireless MVNO. He was a co-founder of Felix. They were bringing machine learning to small to medium-sized business communication. In 2017, along with Anthony, he founded SignalWire, and he is bringing the power of communication to people who aren't familiar with the industry through simple APIs. He and I talked about his talk yesterday. I think you guys are in for a real treat. His talk is SignalWire and Global Microservices. Give it up for Evan McGee.
Oh, thank you. Thank you. And thank you all for coming. I wanted to say, I know that you have many other sessions to attend right now, so I appreciate you coming here and choosing mine. Lots of multi-track conferences. But anyway, I also wanted to give a shout out to Sean Heine, as one of the other co-founders of SignalWire here. And this is Global Microservices with SignalWire. And this is a topic that has been covered at this conference before, and similar ones just like it, that talks about how to deploy RTC in a containerized, sort of Dockerized environment. But I'm going to try to describe it in sort of the unique way that we do it, and sort of how using the best practices that we found over all the years to make it sort of as resilient and as tolerant as possible. And so I think it's going to be kind of cool. I think you'll like it. I think hopefully you get some new stuff out of it, an actual real tidbit or two. There's a bit of technical, a bit of business, and we'll just keep it moving. So yeah, that's me. I am Evan McGee, the CTO and one of the founders. I think Anthony talked a lot about it. What is SignalWire exactly? Just in case no one was entirely sure. We are a technology company that's focused entirely on software-defined communications. And what does that mean, right? We're trying to figure out, we want to build a giant global elastic network that solves all the problems that we, as a group, have solved a lot of times in the past, where we've had to rebuild the same architectures over and over and over again, and build them for clients and build them for other people, or even just rebuild them ourselves at great cost and hit the same little bugs and endpoint nitpicks and edge cases. We want to help do that and then create an API that allows anybody to come use that infrastructure from anywhere in the globe. So there's no more having to deal with very strange, weird edge cases or network inconsistencies or having to chase down, somebody mentioned to me the other day, like a comfort noise packet in the middle of a stream that just makes the audio go wonky. That's the kind of stuff that no developer should ever have to worry about. And we are a very special group. You here who are here in the audience today are a very special group of people who understand this stuff incredibly well. The average web developer really has no idea what this kind of stuff means. Comfort noise, like what is that? That sounds comfortable. It sounds, why is noise comfortable? It's like, well, silence is actually kind of very strange. So it's a very different world they live in, and we are trying to make that accessible to them. We're also rooted in open source, right? Anthony founded the FreeSwitch project. Mike and Brian, along with him, built it over all these years. And now we're here to kind of shepherd that forward and be the steward of that project in a way that we can contribute back to the community and give back and be the people who can help provide some both financial and engineering guidance to try to get this moving even faster into a bigger and brighter future that Tony was talking about. So, what do we mean by sort of an elastic global communications, right? So we have a bunch of nodes all over the world. These are the current ones as of about a couple months ago when this talk was first written. These are the locations of like media and API pops we have everywhere sort of around the world right now. We started originally just with US. We've expanded now. You can kind of see sort of down into different regions, Oceania. We really want to cover sort of everywhere that we can. And we want to have it basically be so that you have sort of very low millisecond latency to anywhere you want to communicate with people, anywhere on the planet, right? You want to be able to call somebody on the West Coast. You don't want to have that go all the way to the East Coast. If you're in Europe, you shouldn't have your calls come back to the US and then back again. And even like your data traffic shouldn't have to do that, right? When you're setting up any kind of command and control, that should all stay somewhere local in regionality. So the question is, how do we do that, right? How did we get started doing that? Why and what do we use? Well, we leverage containers. So can I get a hand, just a show of hands in here, who plays with Docker at all in their day-to-day job? Great. It's so many more than it used to be, and it's so exciting. I can skip the next part because I've had to say it for years. And who now actually Dockerizes their real-time communications pieces? Their Chameleos, their FreeSwitches. Yeah, not nearly as many, right? So that piece is still a little bit wonky. People are still not quite sure about that. But the underlying knowledge of the container ecosystem is important, so I can skip this one pretty much, right? This just kind of tells you what Docker is, why you want to use it, and really how it can help you create like immutable architectural choices that are easily deployable, something that's very fun. but I think you all know. If you don't, come talk to me afterwards. I'll be happy to expound on it, but I won't waste your time here. But that sounds great, right? We all know Docker's great. Docker runs really well on one computer. The problem with it is, right, it's built to be run on an isolated machine. So if we're going to build some sort of elastic scalable thing, we have to basically decide up front that we're going to go sort of horizontal on a lot of this. We've got to make sure that it's sort of idempotent, it can be kind of copied over and over and over again. And how do you do that across any number of machines, particularly cloud servers? Well, you're going to have to choose some sort of orchestration framework to do this. Right, and there's been lots of choices over the years. There's been Mesos, there's Kubernetes now, there's Docker Swarm. You know, I tend to focus on, I get a lot of questions about what's better, you know, any of these different options. You know, Zookeeper if you run Kafka, any kind of thing you want to do to manage clusters. Swarm versus Kubernetes. Kubernetes is obviously sort of the winner in this in terms of like market share and mind share, but Kubernetes is also quite complicated. It's a very complex piece of software. It requires kind of a deep knowledge of and a big, fast learning curve. So if you are unfamiliar with orchestration frameworks and how they all work, I have to recommend that it just doesn't matter. Just pick one. I don't care. I don't care. If you want to dig in deep and go with Kubernetes and just go nuts on that, have fun, just do it. Pick one and get learning on it and build it. If you really want to get started quickly and do something else, right, try Docker Swarm. It's built into the Docker engine. It's actually every time you install Docker, you get kind of Swarm mode built in. It's incredibly simple to get started with and sort of get yourself familiar with how you do large container-based orchestration. It has all these kind of fun things built in, all the kind of things you need to get started, right? Simple to scale. Look at my laser here. Ooh, yeah, that's not very, all right, kind of. Yeah, you can simple scale across multiple nodes. It gives you that ability to now scale these things horizontally. You can get built-in overlay routing, so you have private networking, DNS discovery, eventing, healthcare, all that kind of good stuff. You can have that all to yourself to play with, and you can even run it on one local machine. It's not hard. You can just boot it up and get started playing with it. In fact, I'm going to put this up for later so you can go back to the slides and review it. There's only 3 commands. There's 3 commands to get Swarm up and running. You know, you initialize it right here with an advertising address. You get down here, it gives you a join token. You do the join token down here on a different server, and you're done. That's it, right? I ran that on 3 little instances, one in London, one in New York, and one in Los Angeles. You have a little leader election there, so now you have a master running, and you have a little 3-node swarm, and that's pretty fun. Right now, if you start up a service on that, it can choose which one, it can go between them, and it's pretty great. You can actually scale things up and down. We'll try to find a free node. And there's much, much more to be done here and digging in if you want to make this a production-grade thing. But in order to get your feet wet and understand how you do it, this is a great way to get started. And it does look trivial, but naturally there'll be dragons in this, right? There's all kinds of weird stuff. Here are some tips and tricks. You'll find these sort of online if you look around, but to save you some time, remember that masters operate in a raft consensus algorithm, so they require a quorum, which means you got to have at least 3 of them. You got to have 1 of them, but like you got to have an odd number, right? So they can agree on who's the master and they don't all get in contention. So make sure you have at least 3 or 5 or 7, an odd number. You got to keep the masters nearby each other. I say global stuff like this. The masters themselves are very sensitive to latency between each other, so make sure you keep them close together. Otherwise, you're going to have a bunch of split brain scenarios, and everything just goes to crap. And the last thing you want is to have a call at 3 in the morning because your cluster is split and you don't have an ability to like deploy services or manage them. They are both quite good at self-healing, but that requires more work. If you do end up doing a sort of a big thing, take a look at the dispatcher heartbeat. That's a very important thing in both Swarm, and it's called the node eviction timeout in Kubernetes. Lets you deploy things without having to have them be so close together where the health checks fall apart and the nodes drain themselves because suddenly they think that they are disconnected. It's a way to make sure things stay up and running. And one really important thing, too, and something I want to highlight, and something that we take very seriously at SignalWire, is the idea of security and personal encryption, right? If you come to SignalWire and you sign up today, you're going to have TLS and SRTP by default. We don't charge anything more for that. We think that security is an number 1 priority everywhere, and it's something that's been ignored and people haven't pushed hard enough. So we're very all about that. And one of the interesting things about this is if you're running on multiple cloud providers around the world, because if you want to run a global elastic network like this, you're not going to do it in your own data centers up front. It's too expensive. So you're going to leverage existing commodity VMs or existing commodity data center providers around the world to then do this exact thing. It means you're sending a lot of information around, right? And it's probably, unless you HTTPS all your things, you're sending a lot of unencrypted, very important metadata around. Well, these things have built in some pretty great stuff. One of which is a VXLAN encrypted overlay, right? Gives you sort of a effectively a private internal network that's encrypted, that basically is an IPsec encrypted tunnel between all the different machines. So suddenly you don't necessarily need to worry about having Let's Encrypt internally on all your services because they're running over an IP VLAN to everybody else, or an IPsec tunnel to everybody else. So that's very important to consider if you're sending a lot of information over the public internet that's unencrypted. Just keep that in mind, right? I'm trying to make sure that everyone keeps security at the forefront of their mind for all this stuff. And like I said, no one provider can get you everywhere. We currently utilize all of these guys for different things, right? I know some people here are pure AWS, some people are pure GCP, whatever else. We have found that in order to actually scale and be able to leverage the best both business aspects and technical aspects, it requires you to kind of use all of them, right? Google's got some great networking. They got some great networking, and they've got really attractive services, and their VMs are quite good and more specific. AWS has some other excellent services, right? We love Lambda. We like all their serverless things. We like a little bit like S3, of course. Azure was the only place that has a data center in South Africa, right? How are you going to run big data center in South Africa? You kind of got to go in Azure. Plus, they have Windows, and FreeSwitch runs on Windows. So SignalWire Stack, which is our commercially supported version, runs on Windows. So that's kind of cool, right? That's very few other applications and frameworks in the world are Mac, Linux, and Windows, and FreeSwitch is that, so we can leverage that. DigitalOcean has amazingly great bandwidth costs. Vultr and Scaleways has ARM development, and Vultr does some interesting node locations, right? So we want to make sure we get that latency close to people as possible. We got to find the right people in the right places and use them. And then we test all the machines everywhere to always make sure they're good. Because one VM is not like another, we all know this. And so when you're doing this across multiple providers, suddenly you can't rely on necessarily negotiated IOPS performance or things like that. You can once you get big enough. But up front, you got to kind of profile your own machines. This is not hard. There are Docker containers that will help you profile a machine off the bat. Tie that into your Ansible deployment framework. Make sure the VMs are good before you add them to the swarm. And you're good to go, right? But you got to track the stats over time, make sure you don't have any noisy neighbors, things like that. So this is where we're going to expand into, right? So currently we have all the red ones. We want to expand into all the blue locations. It just requires a little bit more time, but I would like to point out the one down there in South Africa, right? That's Azure down there. It's not a big secret because it's the only thing that's down there, really. They opened that up in March. Does anyone really remember when that was? I think it was March or April, something like that. But within 48 hours, we had deployed our stuff onto that. Right? Because once you have all of this set up and working, you can just spin up new machines anywhere in the world. And the way that we've constructed SignalWire and sort of some internal messaging bus frameworks, we can kind of just throw these onto nodes anywhere we want. And we're excited about that because it lets us expand to anywhere that we think the communications is necessary. That's part of the elastic. And if we had too much traffic in a certain location, we just more nodes in that location, take more traffic, and it all scales sort of horizontally. And these are the kind of problems we've all solved before in RTC. This is not like an unsolved problem. It's just the idea of taking that and turning it on in like 15 minutes or turning on new capacity, like in real time as new things are coming on, and then decreasing it again, right? Doesn't have to have that running all the time for max peak traffic. We can kind of elastically go balloon up and down in any location anywhere in the world. Using a lot of the techniques we all know. We call these real-time regions. Those are backed up. So each one of those nodes is like a data center somewhere, like Seattle, SF, LA. They make up regions, much like Cloudflare. That's a bit of how we modeled a bit of this after. These are like, North America West, North America East, South America North, South America South. They kind of overlap too. And what the real-time regions are basically like data regions. So if you're trying to do API traffic, things like that, think about it as, you don't want to have somebody calling from Bangalore using US data, because if, let's say, someone hits, it's an IVR, right, and you hit 1. We all know this. You hit like 1. You don't have to transmit all of that back to something in the US, have that processed, and transmit that all the way back to India again to actually have that command then executed. That has to be a tight event loop somewhere nearby them so that the command and control is local and actually the experience is good. Otherwise, you're having 5, 8, 10-second delays. And we've seen that on some other platforms where they'll try to set up a call. It might take 8 or 10 seconds. And we've had conversations with people who have to wait 10 seconds. They've actually built into their contact center software delays of 5, 10, 8 seconds while the call's kind of connect in the background and the webhooks get set up. And that's not so much fun. So we wanted to alleviate that. So again, real-time regions are made up of real-time nodes. The real-time nodes have individual little media pops in them. Those are the things that do all the RTC and the API pops. That's what handles the LAML and the relay calls. Yeah, the API pod is kind of just exactly what I said. I covered most of this. So one thing I wanted to get across was, here's sort of a graphical representation and overview of what that sort of means, right? So here's North America West and Seattle and Los Angeles. People are connecting to them. So let's say that everyone is geolocated, right? Part of this, too, is making sure that your media goes to the closest possible thing. Now, you can do that one of two ways, right? Using DNS, you can actually set it as like seattle.relay.signalwire.com, something like that, which will automatically take you to Seattle to force that. Or we'll do Anycast or GeoIP lookups to get you to the closest one. And then all your media, if you're all doing things in Seattle, it's no problem. It all stays close and tight, and everyone stays together. Well, if you need someone in Los Angeles, we can directly connect you across, right? If you have people calling into a conference room or a WebRTC media room and you're down in LA or you're up in Seattle, we will make sure that that goes directly to each other, right? We have them all very tightly coupled in that way. And they share regional resources. These are regional Kafkas, things like that, regional data centers where they can kind of get eventing systems. So you can have basically all of your people in a region using the same eventing. And that can then fall back. This is all cascades back down into the global clusters. Let's say you have a bunch of eventing happening again somewhere in like Sydney, Australia, but then you need them to tie into events in the US, but you don't want anyone to have any unnecessary latency. We have a lot of logic that dictates how that information flows around, again, to try to keep this real time. And that's the problem. As you start working on a global scale, how do you make sure this stuff stays fast everywhere all the time? And fortunately, we've been able to build this from the ground up to do that, right? Part of it, too, is also optimizing the business costs on this, right? Some of these different VMs and different providers have a lot of different variation in cost. And a good example is that we generate a lot of bandwidth, right? We use a lot of bandwidth, a lot of traffic, a lot of metadata dumps out, particularly from FreeSwitch, right? As ESL churns through all those events and stuffs the entire event frame into each one, right? That's coming down at a pretty hot clip, right? That might not be a lot. You can compress that, not a big deal. But it is going to go across to some sort of analysis program. And a lot of the ingress bandwidth, right, on providers is free, right? So you have a big inwards pipe that's all free, pumps down in. You churn through that data down to the data processing layer, like over here, and that then gets pumped out as a little tiny output, right? So these guys who have free, like cheaper output that do stuff sort of locally, dump down into the major ones, processing, pump it out, right? That's a way to help get the virtual machines into a position to work for you. And I think for a long time, people in our industry were pretty hesitant about using commodity cloud providers to do this kind of service. Traditionally, everyone builds it on their own big iron, tries to run that. If I can get across one thing to you today, it's that the cloud providers really are quite good. Like all of the VMs that are out there are more than willing and easy enough to maintain and sustain the business that you want to do. It does take some knowledge of making sure that what you're getting is what you need. And so that's something that, like as SignalWire, we're trying to make sure that you wouldn't have to worry about because we take care of all that for you or for whoever are your clients. But if you wanted to get into this, make sure that you do profile the machines, but they are good. The bandwidth is solid, the performance is great, everything is totally good, and it's cost effective at this point. Let me go back to this for a sec. And so one thing I wanted to get across was also the idea of kind of the webhook versus relay thing. And I don't have a slide in here particularly about it. Something that I wanted to really point out was that a lot of this is predicated on, and traditionally a lot of it's predicated on doing webhook style event callbacks, right? This is all HTTP based, HTTPS kind of stuff. And it's a lot of like command and control. And one thing that we're trying to get across and trying to really like make more real time too is that ability to dig in and do real time WebSocket based RTC commands. So instead of having a webhook callback, you really can get in there with the program and command and control like you're sitting at the console, right? You can play, you can stop things, you can really just like manipulate and do the call any way you want. Same thing with video conferencing. And so you have the ability to move things around, ability to like change regions of stuff. You can actually like move calls. You can actually have video conferences that overlap multiple WebRTC stuff in any one of these sort of regions and locations. And the goal is to make it as close to you as physically possible and as easy to use in your applications as you can. So, yep, so that's me. You know, again, I'm Evan, co-founder of SignalWire. That's sort of a bit of high-level overview of how we're doing our global Elastic infrastructure. Yeah, and I guess if you have any questions, now's the time. Thank you so much.
Big round of applause for Evan. All right, with an in-depth talk like that, usually we have questions. Who's going to be the first one? Up over here on the right, yellow shirt.
So you use Docker Swarm?
Yes, we do. We use Docker Swarm, correct. Have we gone to Kubernetes? We've used Kubernetes for certain things. Yes, we've gotten FreeSwitch to run in Kubernetes and Docker Swarm, correct. Yes, it does. It is one of the things that we've worked quite a bit on, and it is certainly possible, and it does help with the ability to have them. Mostly, one of the major benefits of doing it is the idea that if it dies or something happens, it will respawn automatically. And the idea that you can release new versions, like now that 1.10 is out, if you wanted to spin a new 1.10 and have it just like replace the existing one, you can do all your testing on that with the testing frameworks, and that's a really like powerful part of it. The actual horizontal scaling bit still requires all the usual pieces we need. There's no magic in that makes that work. There's no like, UDP load balancer that can replace Camellia. Like that doesn't really work. So you have to still have all the bits in there. But it does solve a number of issues of maintenance and healthcare and like DevOps.
All right, over here on the right, we had a question. Go ahead. Yellow shirt.
So the question is, if a Docker instance fails, do all the calls on that instance go away or die? And again, it comes down entirely to how you build the architecture of that instance, right? If you're terminating the calls directly into that FreeSwitch, like or something like that, at that machine, and that's all you do, then yeah, certainly it's just gonna be like anything else, right? It's just gonna go kablach. However, if you front that with some sort of SPCs or some sort of logic where they can actually, you can anchor the media and then move it, you can have that box sort of respin back up again, right? And then suddenly you have an identical container right there with the same IPs and everything else. And if you have enough backed up information in like a centralized database, things like that, the calls can be recovered and continue just as normal. The media flowing through, again, it depends where you want to anchor your media. If you anchor it through FreeSwitch, then and that's the only component, then you have a problem. But if you have things in front of that, then you can make it all work.
Other questions for Evan? Back here in the back.
What issues have you had running FreeSwitch in containers? Like is there anything you had to tackle to make that work right?
Sure. The question is, are there any problems we've had running FreeSwitch in containers, and what have we had to tackle? And I will say that there have not been no structural issues, right? That's something even at SignalWire, that's something we've pushed into. Anything that we've found has been pushed into the open source. So if you see stuff from us that's anything related to that, anything that we have located is in tree. And there has not been much. I did a lot of this at my previous company before we founded this one. We containerized FreeSwitch and ran it for the wireless phone company. And one of the things you have to be a little bit aware of is, again, a lot of people get stuck up on the networking, the port issues, right? The fact that you have a user LAN proxy that everything goes through. A couple ways to solve that. Two major ways, really. One is don't use it. Like just run everything in host mode, right? So you just ignore that. You mount the networking stack directly into the container, and you say, screw it, it doesn't matter. Second way is to say, that's fine, we're going to have a user LAN proxy, and then each node's only going to handle 50 calls, 100 calls, doesn't matter. And then you just horizontally scale that way. And it's kind of pick and choose your poison, right? There are ways to combine them that are a little bit more sophisticated that I can get into sort of offline. It's a little bit too complex to talk about, but there are ways to kind of make those work together. But those are kind of two ways. And I think you got to choose which one fits your business and your style of doing it, whether it's small, horizontal, distributed, or whether it's like, larger in one where you just sort of collapse it so the containers become less of like a standalone entity to do their own thing and more of just a way of deploying software in a more contained format.
Right here in the black shirt.
Sure. Sure. Yeah, so that has come a long way, right? Basically that with newer kernels and a lot of the work that Anthony has done in perfecting that sort of stuff and working with timers, that was a huge issue for a long time, right? It was completely unreliable. And if you're using AWS, and sometimes still is, but I'm not here to point any fingers. But yeah, so it's come a long way. I really wouldn't worry about that too much. Like particularly if you're trying to run super high density through the VMs, you'll start seeing that stuff at like, thousands and thousands of calls per machine. But that might be the point where like maybe that's no longer the right way to be doing it, right? Maybe you gotta, yeah. Sure. The question is, based on sort of the kind of the dynamic stuff we've done, how did that change? How does that change the standard monitoring and like tracking, that kind of stuff? Yeah, we've had to build a lot of that. We do use the traditional tools, like everybody. We still run SIP. If you come use us today, like we have all kinds of SIP interfaces, SIP over WebSockets, everything else. So, like everyone else, we run the standard SIP analysis tools. You can't speak highly enough about the guys at Homer and things like that, right? So those are great. We have Verto, right, which is our own internal signaling protocol for WebRTC. We use that for all of our WebRTC stuff. So we have all of our own monitoring frameworks for how we detect and see what's going on with that signaling. Verto is a JSON-based, format that's, a lot. It's different. It's more useful for what we're looking at in the future. And I think that's where we're going, is the idea that SIP is still around and SIP will continue to be a major part of what's going on. But there are new protocols coming. RIP is one of them. There's all kinds of other stuff coming on. There's Verto, as we think of, is like JSON-based messaging is a really important one. So I think you'll see more of this evolving as web tech blends more with real-time communications, and they become less standalone fields, and you see more guys building in React Native coming down, and more of us sort of bootstrapping up into the world of like app development and that kind of things. It's kind of hybridized like that. So we'll get a lot more of the web-style monitoring tech compared with the more traditional telecom stacks. Great. Well, I'm out of time. So any more of the questions? Oh, yeah. To get FreeSwitch on Kubernetes. We don't have it because we don't use Kubernetes extensively internally. I'm sure we could certainly write something up about that. Or if anybody in the community wants to do that, talk about how you do as well. I can certainly say how we do it in Swarm and how we do it in Kubernetes is very straightforward, just to get FreeSwitch and running. And one thing I'd love to do is have anyone in the community who wants to come and donate, I know Better Voice a long time ago put out a container that had FreeSwitch in it that was actually fairly useful with a lot of information. SignalWire will continue to do that and give back and try to create those kind of little things. So maybe that's something we can do, is find a way to show people, here is what you do to get this up and stood up. So that's a great idea. Thanks, man.
All right, wonderful. Big round of applause for Evan.
Thanks, guy. Thank you, everybody.